Good morning. I'm going to apologize for the type of video that I'm having to give you right now. But every time I have tried to do download a program of some sort to take myself on OneNote, it hasn't been working for me. So I'll just throw it out there. I'm an Android user. This has not changed my ways yet, but we shall see, because everybody keeps telling me iMovie would do exactly what I wanted it to do. So I get you people, you iPhone users, but I'm an Android, so now I have this ghetto way of giving you a lesson. So I'm still trying to figure it out, but I wanted to give you something for today. First of all, let's start with a recall. All right, so here's the deal, guys. When you take the derivative of, let's say, x squared, you get 2x. And when you take the derivative of x squared plus 4, you also get 2x. Okay? And so when you take the derivative of x squared plus any constant, you're going to get 2x. All right? So let's use that information and let's talk a little bit about antidifferentiation. So it's the antiderivative. Okay? All right, so if I had 2x and I wanted to know what was that function before I took its derivative, we all know it was x squared. But what we do is we put a plus c because we're not 100% sure if there was a constant there or not. Okay? All right. Now, the notation to tell you to take the antiderivative looks like this. It's called an integral symbol, and it's kind of like a long S. And I'll explain to you later exactly why it's a long S. But right now, we're just going to go with this is the symbol. You put the function in the middle, and then you tell it what your independent variable is. Okay, so we would be taking the derivative, the integral of 2x with respect to x. And we state that our answer is x squared plus c. Again, we say plus c because we're not sure if there was a constant there to begin with. Okay? All right, I'm going to pause it for just a sec. Okay, so here's the deal. When we are taking a derivative and we're using the power rule, we bring the power down and we reduce the power by 1. So when we're taking an antiderivative, we've got to use our power rule, but in reverse. Okay? So obviously, instead of multiplying, we're going to divide. And instead of reducing the power by 1, we're going to increase the power by 1. All right? So when we are integrating and we have an x to some exponent, here's what we're going to do. And this is the order I do it in. I increase the exponent by 1, and you multiply by 1 over that new exponent. That's the same as dividing, right? But we're going to write it as 1 over. Just like if we were dividing by 4, we could multiply by 1/4. And then, of course, our plus c, because we're not sure if there was a constant out there or not. All right, so here's you an example real fast. All right, so if we are going to integrate x to the 5th power with respect to x, it would be x to the 6th power times 1/6 plus our constant c. One way to check your answer, obviously, is to differentiate. Let's go the opposite direction. If you were to take the derivative of this, would you get that? We would have our coefficient. You'd bring the exponent down and reduce it by 1. And sure enough, this gives you a 1, which is your coefficient over here. Okay, so it's all pretty simple. You love it when I say that, so I had to make sure that I threw that in there. Okay, so all we've got to do now is there's got to be some algebra ahead of time, a good bit of the time, okay? So let's say that we were going to integrate a function that looked like this, x squared times x minus 1 dx, okay? Well, you are 100% capable of integrating each individual term. So what we're going to do is we're going to rewrite, okay? Which means we can distribute that x squared and make it x cubed minus x squared dx. So we can integrate each individual little piece. There's all those rules, you guys probably remember them when we were differentiating, that tells you that you can integrate x cubed minus the integral of x squared. Okay, now we're not going to rewrite it like this every time, but there is a rule that basically tells you that the integral of a difference is the difference of the integrals. Okay, but like we did with differentiation, we're just going to kind of start getting to the point where we skip this step here and we're able to go straight to our integral. So integrating this term, we are going to increase the exponent by 1, and we're going to multiply by 1 over our new exponent, minus this one over here. Increase our exponent by 1, multiply by 1 over our new exponent, and don't forget our plus c, because we're still not sure if there was a constant there to begin with or not. Okay, so online you're going to find a worksheet. It looks just like this. It says Indefinite Integration Practice Worksheet. And on it, you are going to have some integrals. Remember that you're working backwards. This one here, we're going to talk a little more about it tomorrow. All right, but don't forget that you're working backwards and it's got some rewriting rules. So again, this first integral will start out as x to the negative 3. You're going to add 1 to the exponent, multiply by 1 over the new exponent. Don't forget this one is x to the 1/2. This one, you know what that function used to be, all right? Down here, remember that you add exponents. This is x squared times x to the 1/2 dx, and so you'll add their exponents, and so that'll become x to the, this is 4/2 plus 1/2, 5/2. And then you'll add 1 to that new exponent, right? Lots of rewriting that has to take place on both this worksheet, and if you want more practice, lucky for you, there's a more indefinite integrals practice worksheet for you to do the same thing. Again, when you get to the bottom, this number 9 and this number 10 need to wait until tomorrow. We're going to talk a little more about that. Okay? Good luck, guys. I will have my office hours today from 11 to 12 and 2 to 3. So I can talk to you then. I'm still trying, again, to figure out something live during that time. It may be tomorrow or the next day before I can get it all figured out. But I'll talk to you soon.